Okay, let's talk about timers. Up at the top of, I'll be running the simulator, not the actual RS Logics, but it'll give you the same effect. Under timer, we've got timer on, timer off, retentive timer, and so on. But you want to read about each one of these. The most basic would be the timer, the T on. So I'll add a few rungs here and grab the T on, and I'll drop it here, which it always ends up appearing on the right hand side. Timers always start as T4, so I'll say T4 colon 0. And then we pick a time base. This is going to be tenths of seconds. On the RS Logics, you have more choices: 1 second, tenths, hundredths, and thousandths, I think. Now the preset, let's just set this at, let's say 50. That'll be 50 tenths, which will be 5 seconds. And as this is timing, you'll see the accumulator counting up. And as soon as it hits 50, the done bit goes on. What we want to do is drag an XIC down here, and we'll use I colon 1/1, and this will be the timer enable. And when we throw this, this will enable the timer. As the timer is counting up in the accumulator, we may want to monitor several of the bits of the timer. So if you want to monitor a bit, you would just say T4 colon 0 slash, let's look at the enable bit. And when this is activated, let's just turn on this output number 2 light. So I'll grab an XI, or OTE, I mean. And of course, you're always going to put symbols and labels on these, but right now I'm just trying to get through this in a hurry. I'm sure you'll do what's right. Output colons, what is that? 2/2/0, and this will be the enable light, and that light will come on as long as this switch is closed and the timer is enabled. So I'll add a few more rungs here, and you might want to monitor a few more lights. How about the done light? So you could do the same thing. Grab this down here, T4 colon 0, T4 colon 0 slash DN, and we can watch the done bit. And if I grab this and drop it down here, make this another one, output colon 2 slash, we'll say 1. And let's just look at this much. I'll let you figure out the TT bit. And if I download this and run it, you'll get an idea on how this thing works. So when I close the switch, is this thing running? Oh, I closed the wrong switch. Let's open that. Close this switch. It's enabled. The enable light's on. As soon as it's done, the done light will come on. The done light came on. So basically, this is what I want you to do, is to show me how the T on, the T off, and the T retentive all work. Okay, another timer application I want you to look at is the is an oscillator. You all know from digital logic, it's often required to have an oscillator that's at some given period of frequency. What I've got, this first timer, this is timer 1 and timer 0, but timer 1 is set up at, what's that, 10 seconds, and timer 0 is set up at 5 seconds. And to get this oscillator to start working, what we're going to do is oscillate back and forth between these timers. Now the first timer, T41, is driven by the done bit of T40. And now when we first start out, this T40 is not done. And that's what I'm checking for. Are you not done? Well, it's not done. So this is true. This timer will start counting up to 100. As soon as it hits 100, this done bit comes on. This done bit activates this XIO, or XIC. When this is executed, this one starts timing up. When this one counts up to 50, this done bit will be done. That's going to make this false, because here I'm saying, are you not done? When this is false, you may have discovered that the done bit, as soon as this goes false, the accumulator gets reset, the done bit shuts off. As soon as that done bit shuts off, that's going to make this false. That's going to turn this accumulator back to 0, shut this done bit off. When this done bit turns off, this will be true again, and the cycle repeats. And this will count up to 100, turn this one on, this one counts up to 50, turns this one on, shuts this off, resets this, resets this, turns the done not on, starts this thing all over again. Now with this particular oscillator, I'm looking at the 4 ones done bit, that would be this guy here's done bit, the 4 O's done bit, that would be this guy here's done bit, and the 4 ones TT, this one here. And one of the questions I want you to answer is how long will each of these lights be on during this 15-second cycle? What's the duty cycle? Let's give this one a shot. So I'll download it, run, and right now T41 is timing, so that's on. That'll be on for 10 seconds. So 10 out of a total of 15, that's 66%. There's your answer for that one. T41's done bit was on for 5 seconds. Gee, the T40's done bit didn't seem to even come on. However, it did come on. If you look at the T40, remember what I said? When that done comes on, that's what's actually going to reset everybody. That's going to make this false, shut this off, make this false, shut this off, and as soon as that's off, then this goes off. So for one cycle, the length of time it took to go from here down to here and reset everybody, that's how long that was on. Now if you wanted to see that actually happening, you could go into the step mode if you time it just right, and you can single scan. Each time I press this once, this will count up. I'm 3, 4, 5. I'd be here for quite a while, but you could shorten these up a little bit. Maybe I can get through this, but if I kept doing this, you could actually see this come on for one cycle. So tell me what that duty cycle is. Now another thing I'm going to ask you to do is do speed control on this. You could actually load a different number into the preset. If I go into the program mode and add a new rung down here, I could actually use a move statement, which are over where right here, and I could move some data into the preset. So the source would be some number. Instead of saying 50 there, let's say I want to move the number 200 in here, and the destination that I want to move this to is T4 colon 0 dot PRE. Now when I say dot PRE, I mean a whole 16-bit word. 200 is going to be moved into the 16-bit word when this line gets executed. But I don't want this to be executed every time. Maybe I want it to be executed only if somebody throws a switch or pushes a push button. So I could just take this and put this down here and call this input number colon 1/0, and that would be this. And let me make that a push button. When I push that button, I'm going to load the number 200 into this. So let's give this one a shot. Download, run. And the thing's oscillating, and the preset on this is going to be 50, which is really 5 seconds. If I push the push button, I'm going to dump a 200 in there instead. So while this thing, as soon as it's done counting, I'm going to press that button. So let it get up to 50, and it's through. Now I'm going to press the button right now. As soon as I did that, the 200 got loaded in there. Now it's going to have a much different duty cycle. So as timing gets a little more complex, here's an application where we have 3 timers end to end, T41, T42, T43. And the last timer's done bit is the one I'm going to use to start the process. Here's the last timer, T43's done bit. And I say, are you not done? Well, it's not done, so this will be activated. So this will count up for 5 seconds. When this is done, it triggers this one. This one starts up. When this one is done, this T42 triggers this one, starts this one up. When this is done, this will be false, and that'll reset, reset, reset everybody. As soon as this is reset, this done goes off, and this will start back up again. So this is called cascading timers. Some of the traffic light applications that you're going to be asked to do, you're going to have to line up several timers. 3 would be good for just one north-south direction, but when you got to do the east-west, you'll have several other considerations to deal with. Okay, and the last topic before I let you fly with the timers and counters is counters. Let's grab a counter, CTU, which would be a counter up. These are going to be C5s. Oh, that defaulted to that without me even clicking on it. That's good. And the preset value, if I press, let's put an 8 in there, for example. What this means is when this counts up to 8, it'll be done. So to count, I'll just grab a bit, and I'll make this a push button, which is input :1/0, which would be this push button right here. Every time I push this, this will count up. And we could monitor the done bit if you wanted to. I could turn on some light at output :2/0, and I could monitor that bit. Now to specify the bits, you say counter 5 :0/dn, so I'll be looking at that done bit. Now once the counter counts up to 8, there's no way it doesn't recycle, so we need a reset. And they have a reset command right here. So if I add a new rung and drop that reset command down here, and I'll reset this counter 5, and I think you just say counter 5, oh yeah, :0. You don't specify a bit number, just say counter 5. I want to reset you when I push this push button. So this will be a different push button. I'll say input :1/1, which would be the second one. I'll change that to a push button. So let's give this one a try. So if I download it and run it and start, every time I push this button, watch the accumulator. Went to 1. Watch the accumulator. 2, 3, 4, 5, 6, 7, 8. The done bit came on. And I could keep counting. It'll keep on rolling past that. And there are other bits associated with the CTU. If you highlight that, press F1, the help screen will pop up and it'll tell you about the other bits associated with counters. Now to reset it, I want to push 1/1, which is this button. Watch, I'm going to press it. Ready? 1, 2, push. I pushed it and it reset everything. And now I can start counting again if I wanted to. Fun, isn't it? Okay, so start working on those counter timers.